Hi, John Valvano here, and I'm going to show you how to use the TExaS oscilloscope. Now what happens is normally we're going to connect up an analog signal to one of the A to D converter pins, and the default pin is PD2. Now it will work for these other pins, PD3, PE2, or PB5, but in this demo I have an analog signal which is derived from this potentiometer tied to the input pin on PD2. The fundamental way in which it works is there is a low priority, high frequency, 10 kilohertz periodic interrupt, which will sample A to D channel, A to D number 1 on PD2, shift it from 12 bits down to 8 bits, send it out the UART port to the PC, and then there's an application on the PC that will plot it. And like I said, there are a number of modes, and I'm going to demonstrate scope mode here for PD3. So what you have to do is you have to set up your main program so that it calls TExaS init, setting up that 10 kilohertz periodic interrupt using scope mode. So I'm actually running the starter code. I don't even have lab 2 done, but that's okay. So build, download, and now I just need to run. Now scope doesn't work unless the program is running. So I'm going to run this, which doesn't do anything because I haven't written any lab 2 programs, but it does run the scope. Next, I'm going to launch TExaSdisplay. Now, there's a couple of versions. This happens to be the newest version. This is 2.5. Now, you can, if you don't have 2.5, go ahead and download 2.5. It's the newest version. The next step is to link the TM4C with this application by opening a COM port. Now, if you know what COM port you have, you could type it in here, but I'm being lazy. I'm just going to do a open next, and one by one, I will go until it finds a COM port that works. In this case, this computer only had one COM port, and this board was at COM port 26. And then I'm going to activate this by hitting scope mode. So I can either go to view, oscilloscope, and there's it's running. Now, if this thing is wiggling, you know it's working. Okay, so I'm going to demonstrate scope mode by moving my slide pot up and down. Okay, and the next I want to demonstrate is 2 function keys, faster and slower, which will change the time rate. Okay, so I am going to run slower because I need to run slower. Okay, you see every time I execute a slower, it will change the scale. Now the sampling rate's still fixed at 10 kilohertz, but the display is now changed. Now I can move my slide pot and you probably see waveform. All right. Next I want to demonstrate, let me move slower one more time. Let me demonstrate the cursor, or the trigger. And there are 2 things you can do with the trigger. You can make it larger or smaller. And you can see this black line here is my trigger, and so I'm going to make it smaller. I'm going to lower the threshold down here where I can measure something. I could have hit the down key, down key, down key, down key, down key, down key. All right. So now I'll do it again. Oops. Uh-oh, my slide pot fell out. All right, right again. Okay, here we are. There we are. So now I'm waving it. All right, so that's me sliding the slide pot. If you want to stop, you can hit the stop button here. You see there's a stop button right there. So I'm going to do a function 8, which will stop the trace. All right. There it is, stopped. If you do have a threshold, you'll see it will calculate minimum, maximum, frequency, period, etc. Okay. Let me go ahead and hit the run again. Now this is a continuous straight line signal. Okay, now this is a continuous straight line signal, and you can see there's very little noise in this. Okay, so in summary, you should be able to sample things, change the display rate, set the trigger, capture waveforms, and see measurements. Let me demonstrate one more feature, and that is the spectrum analyzer feature. Okay, so if you have version 2.5, it has a spectrum analyzer in it. Okay, so function 6 and 7 will change the scale of my logic analyzer. Slower. Okay, so now I'm going to do the same thing. I'm going to slide my slide pot here. And there's the black waveform represents the voltage versus time, and the blue waveform represents amplitude in decibels versus frequency. Okay. All right, so that's the spectrum analyzer. This will be more interesting when we get to lab 5. Okay, enjoy.